Hello everyone, I'm Zhongzhu Zhou. Today I'm going to talk about our work done during my internship in Tencent's WeChat. JSidentify, a hybrid framework for detecting plagiarism among JavaScript code in online minigames. You may wonder what are online minigames. Online minigames are lightweight game apps typically implemented in JavaScript running inside another host of mobile apps such as WeChat, Baidu, and Alipay. In China, almost 1 billion people have played WeChat online minigames, dominating 71% population of China. Essentially, online minigames are HTML5 games without DOM, CSS ever, but they run inside another app. Let me show you running screenshots of online minigames. We can see the WeChat mobile app on the screen. First, we click WeChat. Then we can see lots of online mini programs and games on the interface. Then we click the Winnowing games and it's a spaceship game. You can see the game in the video and we can play this game on our mobile phone on the WeChat. The infrastructure of online mini games is based on JavaScript code. We can see the Winnowing code example on the left, then the code will go through the VA engine embedded in WeChat and its interpreter ignition. Ignition will generate the abstract bytecode as shown on the right. Because of a huge number of users in WeChat online mini games, these games have a great profit. 43 games gains tens of millions of Chinese yuan amounts, causing the online mini games to be the target of plagiarism. In 2018, tens of code plagiarism happens in a day, and there are 21 plagiarism games among online mini games. These plagiarism games have a negative impact on a fair, profitable, and healthy game ecological environments. Therefore, we need to fight against these plagiarism games. So in WeChat repository, there are 4 common plagiarism types. The code example on the left is the fundamental function as the original code. The code example on the right are 4 types of plagiarism example for fundamental function. Type 1, identity code except change in white space or comments. Type 2, plagiarism change code in name cases replacements of identifier with expressions. Type 1 and Type 2 clones are easy to detect, and Type 3 clones are addition of rounded code fragments and gapping, and Type 4 clones are advanced sophistication of operations such as the control flow flattening, nested function, string array encoding, and we can see at the bottom on the right that the plagiarism as a wrapper function to the original function and use ASCII and hex to decode the original code. Overall, Type 3 and 4 clones are hard to detect efficiently. Therefore, we designed the JSidentify framework, whose overview is shown on this slide. A developer submits a game to the WeChat backend. The filter will pre-process the game code and generate simplified code and bytecode. The scheduler then calls the detection techniques one by one. Once the detection technique has detected plagiarism, JSidentify stops. The order of the techniques is decided based on the detection gain. The detection gain is designed to give priority to lower cost and more effective techniques. Then the judge will decide plagiarism based on the similarity generated by these techniques. In JSidentify, we abstract the general process of computing game similarity. First, we define the unit of comparison for 2 games. For example, the technique can choose function or the whole game as the units, and then the technique needs to aggregate the unit similarity to the 2 games similarity. I like to introduce Winnowing paths first. The first technique unit on the comparison is the whole game. The techniques use Winnowing from the well-known MOS tool for plagiarism detection, but we found that it's difficult for MOS to detect type 2, 3, and 4 clones. Therefore, our main contribution in Winnowing paths is to pre-process the code before applying MOS. For example, the orange code is shown on the left. The plagiarism adds an array and a function to represent the variable name, and the plagiarism belongs to type 3 clones. After we pre-process the code, we attend the results on the right. We have done these 3 pre-processing steps before applying Winnowing. The second technique is the swing technique. We found that it's challenging to detect the type 3 and 4 clones. In the swing technique, we use bytecode, a lower level representation that will not be influenced by change from type 1 and 2 clone. We first compute the function similarity and aggregate the function similarity to the game similarity. We use a weighted flow network to aggregate the function similarity. We want to let the length of code from a function as the flow into another function. Thus, we use the weighted flow network as the aggregate technique. It can detect the rounded code on the left. High similarity can result in more flow from a game into another game. Also, if the plagiarism splits the function into several functions, the technique can generate parse flow, and the parse flow can aggregate to a huge flow as shown on the right. The high-level overview of the swing technique is shown on this slide. We define the graph capacity as LCS between the function. We define the weight of the weighted flow network to indicate whether a function can embed it into another function successfully. You can find the details of the string technique in our paper. Plagiarism may change code really differently, but they typically are not able to change the sign or game model substantially. Thus, a plagiarism game has similar sign and controller as the original game. And the game is made of multiple signs, and a sign is a user interface of running a minigame, described by a sign tree. Each node in sign tree represents runtime data such as position and the invoked method of a component like the UI controller, sprite, and action. We conduct a bipartite graph, compute the matched sign tree of the two games, and aggregate them into the whole game similarity. We conduct evaluation for JSidentify too. First, we evaluate JSidentify for general JavaScript code. We choose master.js as our experience subject. We can see the blue frame in the table, and JSidentify reports the highest similarity levels. 4 clones are higher than 19% and 2 are around 18% for all the 6 similar-sized clones. Then we want to evaluate its performance on online minigames. So we randomly select 100 pairs of plagiarism games in WeChat repository of plagiarism games. Then we select 200 non-plagiarism games. The right circle shows the elbow place of JSidentify, and we can set the final threshold as 85% in the production environment. We can see that JSidentify achieved the best effectiveness and still achieve relatively high recall with a high threshold. High recall indicates detecting more plagiarism. In addition, we evaluate the best F1 score and average time consumptions. JSidentify has the highest F1 score. Although its detection time is non-trivial, it's still reasonable in WeChat application setting. Finally, let me introduce our deployment experience in WeChat practice. During 11 months of deployment, JSidentify has performed 1.5 billion comparison among 200,000 game versions for tens of thousands of online minigames. JSidentify detects 21 plagiarism games in 2018, and currently, JSidentify helped reduce to 4% plagiarism games. But plagiarists continue to obfuscate code for further attempting to escape the detection. Detecting plagiarism code in JavaScript is still a long-standing challenge for our ongoing and future work. In summary, we have presented JSidentify, a normal framework for detecting plagiarism cases in WeChat online minigames. We have illustrated 3 JSidentify techniques proposed based on different levels of code abstraction. Our evaluation results show that JSidentify outperforms other existing related approach and achieves the best performance. And thank you for listening, and you can check our paper for more details. And I'm glad to answer any question you may have.